All right, let's get going. We appreciate you guys taking the time today. Just trying to respect everybody's time schedules. We're going to be targeting a short webinar for around 30 minutes. The challenge is to provide valued information to everyone. We have webinar veterans to some people that are brand new to Kyntronics. We'll try to give everybody something. So we're going to be reviewing hydraulics today, hydraulic replacements. We're going to be talking about some of the advantages of hydraulics, why hydraulics are used today, and of course some of the challenges. We'll be talking about the considerations on replacing hydraulic, what are the technologies out there, what's being done today. And of course, we'll talk about the Kyntronics solution. And at the end, we got about a dozen or so applications to spur some thoughts, converting over from an HPU to electronics. It's a large portion of our wins is converting hydraulics over to our SHA. So hydraulics, what's it about? In my past, I always walk past these hydraulic power units, the fingers in my ears, my pants rolled up a little bit, and walking a little gingerly, making sure we don't slip on my rear end. And that's about all I did with hydraulics. I tried to avoid them, didn't know much about them until recently. Hydraulics there's a lot of advantage with hydraulics. It's relatively simple and it's been around for a long time, and it's a large market out there. So for those of you who are not familiar with hydraulics, you have a pump that runs continuously. There's all kind of different varieties of these sort of things, but this is in general. Pump runs in one direction. Motor is connected to it, running continuously. You have a relief valve, your reservoir, your filter in the reservoir, flow direction valve, possibly a flow control valve and check valves. So all kinds of different varieties, and of course a cylinder in multiple cylinders you can parallel up as needed. This is kind of the overview of the hydraulic system. Again, it's being used all over the world in many different applications. $12 billion market. The electrical is growing a little bit quicker, and the hydraulics are not going away. So as mentioned, there's a lot of advantages on hydraulics. Just kind of go through these. Robust, it's proven technology. There's a lot of technology regarding seals and trying to prevent leaks, etc. And it's some of the things that the SHA is taking advantage of. They're compact and powerful, withstand shock loads. They're known, hydraulics are known to withstand shock loads with no issues whatsoever. EMAs, other electricals are not so good with shock loads. High speeds, high forces. Again, a nice advantage with hydraulics. You can just add large motors to HPUs. You can go very fast and high loads. That's a challenge for some electrical solutions. Self-lubricating, of course, with the oil. They can run into extreme positions without any issues. Some applications run into the end stops. Obviously, you can't do that with mechanical devices. Those you'll have to throw away pretty quick. You do that a couple times. High temperature tolerance, no sparks in those environmental challenged places, hazard places that don't like sparks. They use hydraulic cylinders. Constant force, regardless of speed. That's a nice feature with hydraulics. That's somewhat a challenge for electrical, because you have your torque is power over speed. As speed changes, your torque changes. So maintaining constant force is somewhat a challenge. Low inertia, that's another advantage on hydraulic systems. You have small little servo valves going back and forth pretty quick. You have a large motor, and on electrics, you have this ball screw or something rolling that is working against you regarding inertia. So that's an advantage on traditional hydraulics. You can quickly repair them. There's inventory on the shelf, no mechanical metal wear items. You can run multiple cylinders on one HPU. No mechanical brakes required, so you don't have to have that extra cost and energy running those. And you have the ability to view pressures. That's nice to have. A lot of mill people are used to just walking up and looking at the the pressure reading, forces area times PSI. You know the PSI, you know the force. Sometimes we use that for PM, preventive maintenance type things. So all that is, those are nice advantages. Of course, there's also some challenges with the hydraulic world. The pumps run continuously. That's an inefficient thing. They're oversized, they're noisy. The pipes, the hoses, environmental issues are challenging. Temperature variations. So a lot of these, especially the open loop systems, you're going to get a different result when you first start up the system to in the middle of the day, or even when it gets nice and hot in the middle of summer. So that's always a challenge with hydraulic systems. That floor space thing, again, their size to run a finite number of cylinders. It's an advantage, but it's also a disadvantage regarding the flexibility. Some transients with the solenoids popping on and off. It causes leaks, causes premature failures in the hoses. Those of you who are familiar with hydraulics are familiar with that. Complex control loops. There's only a few companies out there that really are into hydraulic control, and it's not really available out there in PLCs and logic. And so the more complex, the more money and the more challenging your system is. And it's also difficult to connect to field bus, integration, diagnostic, data acquisition, etc. So those are the challenges. Then there's the intangibles, the things that you're not aware of, or some people are not aware of, or don't take into consideration when applying another system. You have your procurement person looking at their desk. They have an RFQ or a quote from a local hydraulic distributor having a cylinder, an HPU, and some hoses, and then they have another quote, possibly a little bit more for electrical. But things that aren't taken into consideration are some of these in engineering and design. That takes some time to get that all engineered and buttoned up into a machine. With the electrical world, it's just here's a model, fit it in your machine, connect up the wires, and you're off and running. Installation time, bending all those pipes, the hoses, connecting all that up onto the machine takes time, and there's money associated with the maintenance costs associated with hydraulics. Of course, that continuously running motor, we'll talk about that in a little bit. Floor spacers cost, the downtime, environmental cleanup, and then you got to dispose it. So these are all dollar numbers that need to be taken in consideration when looking at the hydraulics world. So down below, I won't get into all this, but just for example, for a 10 horsepower requirement to move a load, if you're to size a single HPU, you have to oversize that a little bit. The cost of continuously running that at that nominal $800 per year per horsepower type number, that's about $12,000 per year, comparing to an SHA, 10 horsepower SHA, 30% duty cycle, only $2,400 a year. Because it's power on demand, it only runs when it needs to run, and that's a significant savings. So that's just alone that pays. Somebody pays this bill somewhere. That of course needs to be considered up front in that education thing. So some of the considerations to replace hydraulics: understanding the machine, understanding what kind of controls are out there right now. Is it open loop? Is it closed loop? Some machines have binding and things on them, and hydraulics just plow right through it with no problem, especially in the open loop mode, just going at a certain flow. And if you put a servo control, then there's binding on the machine, you could have some challenges. That's just something to be aware of. Understand the cycle time, the load zones. The more information you know, the more cost-effective the solution is going to be. If you know just the lower inch of the extend stroke is the load zone and the rest is pretty much not under load, and we can properly size the system for you. Understand the system response needs, some of the inertias in the system. It's important, as well as the counterbalance needs. Counterbalance is used in the hydraulic world as a regen device. It creates heat, but it's a device that needs to be compensated in the electrical world for regenerating. This, for example, if you have a rod pointing down, you have a large die set on the end of the rod, that's going to be pulling. You're going to be having to regen and hold that back. And a counterbalance does that. In the hydraulics world, just being aware of that. You can do some simple mass calculations to understand horsepower needs. Reliability is an important aspect, hydraulics versus electrical. The other point is to educate the customer on potential enhancements with the system electrical. You can have a lot of advantages with electrical, basically no cost. You can do all kinds of nice things for the customer that they may not be aware of. We'll talk a little bit about that in a slide or two. Build story, gather as much data as possible. Take some videos, know the hydraulic rod sizes so we can help size things, even the size of the HPUs, nice to know. You know the operational pressures during the process, that's an advantage. Environment, your temperature, moisture, some debris flying in the air, even the orientation. All these things help us throughout the process. I know, obviously in the beginning, you don't have to know all the details for ROMs, but and also not every hydraulic system can be converted. Some are large systems, some need to be high inertia type things or your disadvantage. So just consider all these things together and we'll help let you know what we can do for you. So some of the electric, some of the advantages on electric, of course, it's ease of control. All the PLCs out there, you know, your standard PI loops can run the EMAs with no issue. It's easy to modify if they want to change a certain parameter, change the speed, change the force. It's easily done with hydraulics. You got to get out there and possibly change out valves and all kinds of things in hydraulics, rearrange your hoses. Of course, the power on demand, you only use power when needed. No hoses, no leaks, flexibility, field bus connectivity, data collection, diagnostics, etc. And then the EMA world today, what people are familiar with is your Acme ball roller screw, and when you get into large horsepower, they become expensive. So the SHA, I haven't talked too much about it, but it truly combines the advantage of both technologies, EMA and hydraulics, and it does solve the challenges. So comparing the SHA to some of the EMA challenges itself, gears, of course, you have metal wear. There's no metal wear with the SHA. Shock loads, of course, the SHA we'll talk about in a little bit is a hydraulic servo actuator. There's no issues with shock loading. EMAs require some maintenance to keep things greased up. There's no maintenance, it's constantly lubricated. EMAs have a finite life. There's no finite life with the SHA. The rod seal in cartridge type replacement, you can do that in the field or we can do that for you. For the EMAs to do nice force control, they need to add load cells. You can simply use an internal pressure sensor with the SHA. Require a brake. The EMAs require a brake. Simple check valve will lock in a position. Of course, brakes add cost and energy to hold it open during operation. There's backlash issues with the EMA. Preloaded for precision. There's no preloading required, no backlash required. Of course, costs get pretty expensive for the EMAs and the larger loads. The SHAs are cost effective, and you can talk about IP ratings. Even some EMAs, they emulate hydraulic cylinders. Why not just get a hydraulic cylinder? So some of the challenges for the hydraulics compared to the SHA, of course, the pumps run continuously. They're oversized and they're noisy. On-demand power, so the SHA only runs when power is needed. The pipes and hoses, contamination issues. There's no pipes. It's totally sealed. There's no ventilated to the atmosphere. Temperature variations, viscosity changes in the hydraulics. The servo control compensates for any viscosity variations with closed loop control. Doesn't matter what the temperature is, it's going to do what it needs to do to make sure the rod gets in the right position. Floor space, of course, is compact at the SHA. Back driving through the valves, hydraulics, challenging there. The SHA can be, if desired, you can put it in float mode and push it back and forth if you want that feature. The hydraulics are sized to run a finite amount of cylinders, so you have a whatever 50 horsepower motor running 5, 10 to add. It becomes challenging. You can obviously add easily with the SHA as needed in the future. It's a fairly flexible design. Transients, that's always a challenge with hydraulics, switching on things on and off. The servo control, S-curves, ramps, nice smooth motion to run your parts, higher quality, complex control loops. Again, it's with the SHA, it's all the standard control loops, all the standard features that are available today, and all the standard PLCs. And with those PLCs, you have your field bus integration and diagnostics and everything available. So tell me more, you're saying. What is this SHA about? So those of you who are not familiar with it, it's basically it's a closed system. Motor, servo motor, runs a reversible pump. You run the motor one way, it pushes fluid into the red, pushes the cylinder up. Run the other way, it pushes it down. Hydrostatic sealing, you can get various size gears and changes your flow. Of course, it increases your torque a little bit. Hydraulic circuit, closed loop control, 4-quadrant control, positional or force control, all involved or all available in the SHA. You have some relief valves that act like a clutch itself. Again, simple circuit, a lot available. Going quick through this. There's more. We can do a deeper dive if you wish. Just let us know. Some example product configurations. That's the beauty of hydraulics. It can be orientated in all kinds of different ways to fit into the machine. It seems like every one of our orders, hey, I need this to fit this way and that way. We're going back and forth. Well, can you give me a 90-degree? Well, that doesn't work. Give me a 90-degree middle. All right, that works. Or in line instead of a parallel. Anyway, going back and forth to fit in the machine instead of having the machines being redesigned. So this is a nice feature. It's just we're just moving fluid. Mechanical actuators have a lot of challenges to do that. So some say, hey, yeah, but this is hydraulics. And my customer says, no hydraulics. And that's what we do is usually point the customer to other places in their shop using like gearboxes and things. Those gearboxes have more fluid than ours. So just as an example, a 10,000 pound force actuator, 8-inch stroke, it's only 14 ounces of fluid. So even a worst case scenario with a forklift, it's just a mop out there and you're good to go. All-in-one solution, so that's something that we promote. The all-in-one, we can eliminate the finger point, we can provide a whole complete solution for you. We have a lot of partners out there that can do the same thing for Rockwell, Siemens, you name it. So we can also provide the actuator alone. Our partners can do the rest of it. At the end of the day, it's to the customer, it's the all-in-one total solution. We help up front, make sure we size the motor appropriately. We can help with that as needed. So if desired, the all-in-one is available. So jumping into some of the examples. So this is one application for use 11 actuators. This was early on. This particular customer wanted to replace their hydraulics. You see this crazy mess of hydraulics. The floor is full of, there's all that grating underneath. And so you see over here, no hoses. This is just a snippet of a few machines running. Again, 11 actuators range from 5,700 pound force to 23,000 pound force. Reduced maintenance, increased the throughput and quality for this particular customer. On demand, of course, at the end of the day, they're saving money in the plant itself, saving floor space for other machines, etc. So in the packaging industry, this particular one's a blister pack machine. This SHA replaced multiple cylinders, power on demand, more efficient, quieter, provided a unique configuration to fit into their machine. And you can see the configuration here. Just a parallel wouldn't work. Metal forming press for airbag components. Another example, 8,000 pound force actuator. Again, the customer required no hydraulics. You're going to hear this theme through several more of these. Excuse me. Improved process control using position and force control. This particular customer was an OEM, or is an OEM. Dry ice pelletizer. They wanted the whole all-in-one. They want to eliminate their HPU, eliminate their PLC cabinet, their relay logic. They had miscontrol boxes around, so they wanted just a simple solution. So what we provided them is two things: the actuator and this control box. We integrated some of their relay logic into our controls and eliminated all this, made a nice little compact package of them, eliminated the hydraulics, the potential for hydraulics getting contaminating the dry ice, etc. So this was a nice win. Punching and piercing operations and coining operations. This was a 58,000 pound force. As I'm going through these, the loads range from a couple thousand to 80-some thousand pound force. So it's all over the board. It's just not the high end. We're also doing the lower ends as well. Same thing with this. The improved process control was important. Nice clean machine, no hoses. Again, the end customer required no hydraulics on this particular machine. This is a hydroforming machine. Shear axis, a clamp and punch axis, shuttle axis. The new machine produces 25% more parts in a smaller footprint. Eliminated the HPU hoses and other hydraulic components. Improved process again. This particular one used Rockwell automation, Allen Bradley, motors and controls, etc. This example is a food processing end user example. See kind of a different look to the actuator. This was an IP67 actuator. The SHA's total enclosed motor you see here. This required a caustic washdown, so the whole actuator was coated in epoxy. For a food processing plant, the actuator shuttles racks of meat back and forth, 55-inch stroke. This was only a couple thousand pound force actuator. Again, we provided them a total solution, stainless steel, etc. So this appliance manufacturer, this is a good example. This particular customer and user had a plant in Texas. We provided them a solution years ago. It was one of the early on. They loved this design. The OEM loved the design. It eliminated the hydraulics on their machine. In fact, this particular OEM had multiple similar machines on their plant at the time. Walking through their plant, you had one machine with hydraulics, one machine that was clean with no hoses on it. The customer loved this design. It's actually now going through multiple plants in multiple locations across the country. This particular one is going to a new plant in the southeast. 14 actuators, 7 clamps, 7 pierce. Duplication for spares. Industries are appliance, automotive, forming. that's the appliance manufacturer. Welding manufacturer, this is a yoke press. This particular yoke press presses yoke onto the drive shaft and holds while it's being welded. You can see the bellows on the drive shaft itself. Just a little different design. This particular customer wanted everything to be the same type of actuator for spares, 84,000 pound force. Eliminated the HPU, of course. This example, again, staying with the same theme, eliminated hydraulics. In fact, this particular customer had an HPU before. In this environment with wood chips flying around, the HPU caught on fire and caused all kinds of damage. So they said, we're not going to go down the HPU road anymore. They wanted electric. Electric had issues. EMAs had issues with reliability. So we were a nice solution here. This had an 8,000 pound chipper at the end. So there was definitely some regen situation that we solved. So again, we provide them the all-in-one solution. Just connect it up. Their PLC tells it where to go. And this is running in the forestry lumber, and we all know how busy that industry is. Uptime is critical. Like truck axle assembly press, 45,000 pound force assembly actuator. Again, same sort of thing. It's nice and clean. You can look at these pictures here. This is a big actuator. No hoses. So this particular one was an AGV, a DC, so it had batteries on board. In the past, they had a battery running a DC motor and an HPU on board. So of course we can all appreciate the headaches with that. So you have this was only a 2,000 pound force actuator, 24-inch stroke. They purchased 3 of these, and again, eliminated hydraulics on board, so it saves them some space, saves them weight on that. The all-in-one compact solution. So again, this is a 48 volt DC solution, eliminating the hydraulics. This particular example is one that the military came to us for. They needed us to lift something, large load, and it needed to be quick. So our standard design could not do that as just off-the-shelf product. So what we did is we paralleled various power units together. So that's available as well. As you can appreciate, it would have taken somewhere in the vicinity of a 50 horsepower motor, and those are not really available in the servo world. So we took an off-the-shelf power unit, paralleled those up, and provide them the speed. The big thing was the speed. The pressure was no issue. The big thing was speed. So paralleling up the power units, providing them the appropriate speed. This is just the power units itself, standard power units. So again, you can parallel these up, use our standard off-the-shelf power units, standard motors, and this is a solution to run faster if needed. So in summary, wrapping things up, the SHA Advantages, single source solutions available from us, including our partners. No hoses, no threaded connections. Power on demand is big. It costs money to run continuously. Lower overall cost of ownership. Those intangibles, don't forget about those. It's a quiet solution, takes up less space. Minimal maintenance, much more reliable solution than the EMAs that are out there. Versatile configurations. It's accurate, simple control, available to everybody can do that. You don't have to have these special, unique PLCs out there. They're only running hydraulics. You have the field bus connectivity, and it's easy to upgrade. Okay. So I have a question that says, what is a typical delivery? Typical delivery today is, standard is 8 to 10 weeks for the actuator. I'm sure you guys can appreciate the motors and drives sometimes are out there a little bit further, but for the actuator, we can easily do 8 to 10 weeks. So I think another, can you run any exotic fluids? We can run different fluids. I'm not sure what is meant by exotic fluids. For example, we can run fluid that is okay for the food industry. But so the answer is yes. We'd have to make sure it's good for our with all our seals, and if it can run with our seals, it should not be any issues. What is the ultimate limit for shock loading of the SHA? Critical pressure. So we run at 3,000 psi. That's you can easily go to 4,500 with shock loads, and our relief valves trigger, and depending on where we set the relief valves, that'll be your shock load, and that's anywhere from 3,000 to I believe 4,200 psi that you would then the relief valve would kick in. We talked about delivery. How does Kyntronics go to markets? We have channel partners, we have reps and distributors out there. Pull this up. And if you have any questions, we'll get a hold of you, Dave. Have you already recorded this? Yes, it is being recorded. It will be put onto our website. How available is it for 40 to 130 inch stroke? We've done 10 plus feet actuators, so it's definitely a possibility. Stroke is not an issue for us. Everything is scaled appropriately. So duty cycle, can they run continuously? Yes, we just need to size things appropriately, and our application team will work with you on that. Even in a worst case scenario where the temperature is really high and the ambient's horrible, we can do cooling, external cooling, and things like that's available. Water glycol, we've done that in the past, but if there's a specific need, we need to understand what that need is. But we prefer not to do that. But there are ways to accomplish that as well. Is there a minimum force level? Yeah, that's a good question. That's always a topic that we have to discuss with you. Of course, we're not a ball screw. We're not going to be competing against simple Acme type screws and a 100-pound force that people are looking for hundreds of dollars. But there are solutions out there that we can do low force, high speeds. You get higher reliability, the all-in-one, the shock loads. So depending on the application's need, we could be a good fit. So there is not a minimum force level, and it really depends on the application itself. Why the name Kyntronics? It was developed over some time. You have control and kinematics type thing, and it kind of evolved from there. Where am I? Yes, we'll send a presentation out to you guys. Yes, I'll provide you, Victor, or somebody, or Rick will, or somebody will provide you a 48-volt motor solution. We're flexible on that. If you have something in mind, we can take care of that. What is the more expensive arrangement for a third-party motor? Do you have a restriction on shafts? Yeah, okay, yeah, good question. No, there are no restrictions, to be honest with you. Of course, we have our standards. Depending on the motor plate, we may have to do a different motor plate. You may have to add costs, but our standards are our standards right now. But there are no restrictions. If you want to add a different third-party motor, we can do that. What we like doing at our facility is taking the motor, putting it on, and running it with the motor. We prefer to do that. But even if you guys can do that or somebody else, that's not an issue. We have restriction on the shafts for mounting it to the actuator. We prefer a key. We use the Zero Max couplings, and that's what we prefer there. So there's no restriction. It just could add some cost depending on non-standardness. So next, along with this, heat management, cooling issues. So yeah, so cooling, I think I mentioned we use fans right on the pump, and if we can use external cooling, that is available. So Dave, we can review the SHA schematic. It'll be in a presentation. It's on our website as well, and we can go through that with you one-on-one. Let's see here. The next is if food applications engineering will press stainless as opposed to epoxy coated. Yep, of course, there's money involved for stainless. Epoxy coating isn't too bad, but yeah, stainless is also available. 48-volt motor available for continuous use rather than intermittent. Yes, it just needs to be sized appropriately. Okay, website, and I think that's about it. Sorry for the fumbling here, trying to figure out how to pull up these chats, but if you have any other questions, let us know. Feel free to contact me or your local rep or your RSM or your distributor. Again, appreciate your guys' time. Thank you very much, and we look forward to working with you.